Okay, so to avoid y'all being lost, let's go ahead and pay attention up here. Example 6. Did we do this one yesterday? Let f of x equals e to the negative 2x from 0 to infinity, and let R be the unbounded region in the first quadrant, bounded below the graph of f. Find the volume of the solid generated when R is revolved around the x-axis. Okay, I get this. E to the negative 2x, I think we briefly saw something similar to that up here with e to the negative x. So we can pretty much determine that e to the negative 2x goes to the x-axis fast enough to make the area converge. But this is not an area problem. This is a volume problem. So e to the negative 2x would look something like that. There's the horizontal asymptote. And now we're going from 0 to infinity. We can actually start at 0 here because e to the x is defined at 0, unlike the power or the p series, which had a vertical asymptote there. So we had to start somewhere to the right of 0. So that area should be finite. Would you agree? It's an exponential, so it goes to the x-axis fast enough. But we have to take that thing for a spin around the x-axis. Okay? Take it for a spin. And that's going to create what will appear to be like an infinitely long trombone bell. Okay? Which very similarly looks like Gabriel's horn or Torricelli's trumpet, which we'll talk about at the end of this section. Once we define the region, we need to decide how we would want to slice it, regardless of what the axis of rotation is. How would you prefer to slice the red region? Vertically or horizontally? I would say vertically. Good. All right. And it's going to work out perfectly because the top curve is always the e to the negative 2x, and the bottom curve is always the axis of rotation. So if our axis is a horizontal line, that is the x-axis, and our slice is a vertical line, or again, that is perpendicular to, you were saying parallel. It's a fun word to say, but not really related to this problem. Okay? And this one's a disk and not a washer because our region is butted up against the axis of rotation all the way across from 0 to infinity, which is that way. All right, so we're going to use the disk method. So this ends up being our radius right there. So the volume is going to be what? What goes out front for the disk method? Pi. Sum of the infinitely thin slices from 0 to infinity, good, of r squared. Dx is the thickness, and then r is just top minus bottom, so it's e to the negative 2x minus 0, which is just e to the negative 2x. So there's your setup, and it is an improper integral. Let's go ahead and simplify it. That's pi from 0 to infinity of e to the, what do we do with the exponents when we exponentiate? Multiply. So that's e to the negative 4x. Now, do you think this one's going to be a finite convergent integral? If e to the negative 2x goes to the x-axis fast enough, e to the negative 4x definitely should, right? Yeah. And we got a little pi out there. So let's go ahead and practice free response. Okay. So we'll have that equaling then the limit as b goes to infinity of pi, the integral from 0 to b of e to the negative 4x. Free response notation. New column over here. Finding the antiderivative, we have an inside function of negative 4x. Its derivative generates an unwanted negative 4, so we'll have a correction of a negative 1/4. So now we have negative pi fourths out front, and then the antiderivative of e to the blob is e to the blob. And we evaluate it from 0 to b. So evaluating it now, we got the limit as b goes to infinity. I like to leave my negative pi fourths out front. It's entirely up to you what you do with it. And when I plug in, I get e to the negative 4b minus e to the 0. And now I can evaluate it. I got negative pi fourths. What happens to e to the negative 4b as b goes to infinity? It approaches e to the negative infinity, which is 1 over e to the infinity, which approaches 0. It gets smaller and smaller, approaching 0. And, of course, e to the 0 is 1. And so it didn't look good having a negative in front, did it? Because we're finding volume. Volume has to be like area, positive. But now it works out. We got a negative pi fourths times a negative 1. We end up with positive pi fourths. So there you go. That is an infinitely unbounded space, three-dimensional space, but it has a finite volume. So if you think about it as like a infinitely long trombone bell, a bottomless trombone bell or funnel, if you were to somehow be able to turn it upright and let the bottom run down forever and ever and ever, this says you could fill the entire thing up with pi-4 cubic units of paint. It'll eventually fill up to the brim. That's pretty cool, even though it's bottomless. Wow. 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 Okay, have a wonderful, fantastic lunch, and we'll see you afterwards.